Good afternoon, students. Good morning. In the today's class, we are going to start with a new chapter. Is polymers. Okay, so this carries 5 marks, only the 5 mark question. So in the last part 3, 5 marks question will be there separately from the organic chemistry. You have to answer any 4 among 6. So in that, the 5 marks question is compulsory from this polymers. No 1 mark, no 2 mark, no 3 marks. Directly 5 marks, 1 question. Understand? In that, 2 plus 2 plus 1 or 3 plus 2 like that. Okay? So it's a very easy chapter and you can easily get 5 marks. Because only they will ask the monomer units and their structures, their polymer units. Understand? So I'll explain. It is quite easy. So students, first one. In this polymers means, you know, poly means many, mer means unit. Understand? Poly means many, mer means unit, a single unit. So the bond formed by the continuous or a repeating structure of a monomers is called as a polymers. Understand? That is called polymers. One monomer unit continuously bonded with each other either by addition or by condensation or any other methods. Okay, that is called as polymers. So this polymers, in this chapter you are going to study the classification of polymers, how they are classified based on nature, based on source, based on their intermolecular forces and based on reaction they occur. Okay, their classification and example, and also monomer unit and polymer unit. Only this much. Understand? Classification and the polymer units. In that, students, read first. In the classification of polymers, 4 classification is there. That is based on source, based on structure, next, based on intermolecular force, last one based on polymerization. Okay, 4 classification are there in polymers. One is based on source, based on structure, based on intermolecular force, and based on polymerization. So based on source means from where they are occur, or from where they are available. Okay, so in that, students, again the classification is natural, synthetic, and semi-synthetic. Understand? Natural, synthetic, and semi-synthetic. Okay. So next, students, in the structure, they are linear, branched, cross-linked. Linear, branched, and cross-linked. Next, based on intermolecular force, they are elastomers, fibers, thermoplastic, and thermosetting. Thermoplastic and thermosetting based on intermolecular forces. Next, based on polymerization, 2 types is there. One is addition, another one is condensation. Addition and condensation. In this addition, student, homopolymer and copolymer, 2 types are. In this addition, homopolymer as well as copolymer. This is the classification of polymers. Understand, students? Only based on this, the mass 2 marks question means what is natural? What are natural polymers? Give an example. What are synthetic? Give an example. What are semi-synthetic? Give an example. What are linear polymers? Give an example like that. What are those? And give an example. And difference between these two is very important for 2 marks. Difference between thermoplastic and thermosetting polymers are very important for 2 marks. Understand? And this one. Addition and condensation is also important for 2 marks. Most important element. The mass anything, but most important is this. For 1 mass, that has elastomers, what are linear? Okay, polymers, what is branch, what is crust. Okay, among those, these are very important. Most often asking questions. Understand? So we will discuss one. So students here, from the source. From the source, that is natural polymers. Right? One by one. First I will explain from the source. Okay? In that, natural polymers. The source means from where they are occur. Natural polymers means the polymers which are derived from nature, are obtained from nature. Okay? Polymers derived or obtained from nature. Called as what? Natural polymers. Okay? So example for this is natural rubber. Okay? This is example. So students, for this natural rubber, structure is there, monomer unit is there, polymer unit is there. I will explain later. While explaining the structure, monomer unit and polymer unit, I will explain this. Okay? This is natural rubber. Next, proteins. In the last, while explaining the biomolecules, I told proteins are the polymers of amino acids. Correct? In there, amino acid is the monomer unit. That is what example for a polymer. Protein, starch. Starch means they are polysaccharides. Polymers are saccharide units. Understand? And also cellulose, etc. This is what? Natural. Next, second one is synthetic. What is synthetic means? Synthetic. Yes, the polymers are prepared artificially. Means from industries or from labs, anything else. Okay, so our polymers are prepared artificially are called as synthetic polymers. So these are also called as man-made polymers. Okay, so example for the students, you know the 5PVC. Polyvinyl chloride and the cloth, polythene. Polythene covers, you know. Correct? Polythene, PVC are the example for man-made polymers. That is synthetic polymers, which they are prepared by using any monomer units or chemical substances in the laboratory or industries. Okay, they are prepared by human beings. Next, last one is semi-synthetic. What is meant by semi-synthetic means by taking a natural products and natural polymers. They are modified. The chemically modified natural polymers are called as semi-synthetic polymers. The source is natural polymers only, but they are made into a different compounds or different polymers in the laboratory by using different chemicals. So, what is semi-synthetic means? Chemically modified natural polymers. Okay, chemically modified natural polymers are called as semi-synthetic polymers. Understand? So, students, here the example is, rayon cloth. Rayon cloth in the iron box image. Silk is there, cotton is there, nylon is there. Similarly, rayon also there. Rayon is a cellulose acetate. Cellulose acetate called as rayon. So this is used in textile industries. If you don't see anywhere the rayon means, you go and check in the iron box. Okay, so in that the different cloth arrangement each with respect to the different cloth materials for cotton, silk, nylon. Understand? Like so, in that rayon is also the option. The rayon means cellulose acetate. This is another one is synthetic rubber or one synthetic rubber. This is also called as vulcanized rubber. Vulcanized. So these are all the examples. Semi-synthetic natural, semi-synthetic polymers based on source. Understand? So in the source, if they occur in the nature, they are natural polymers. So example, natural rubber, protein, starch, cellulose. They will occur and you know that. Next, polymers. Sorry, synthetic polymers. Polymers which are man-made are the polymers which are prepared artificially are called as what? Synthetic polymers. Example is PVC, polythene, and also polyvinyl chloride is there, polythene is there, polystyrene is there. You know class? Polystyrene, Teflon is there. Those are all example for what? Man-made polymers. Next, semi-synthetic means by using natural polymers, we are going to prepare an artificial polymer. Understand? The chemically modified. It is not prepared, it is just modified. Cellulose means always a monosaccharide unit is there. The acetate group is inserted. Okay, the glucose is converted into what? Acetate. So cellulose acetate, the chemically modified natural polymers are called as semi-synthetic polymers. Understand? This is what based on source. Natural, synthetic, semi-synthetic. Next we will discuss based on structure. Okay? Next one is in the based on structure. The first one is linear. Based on structure, first one is linear. Linear means straight. Okay. If the polymers has long chain, if the polymers has long chain called as linear polymers, or if the polymers has a long chain linear structure. Long chain linear structure. So students, listen, I will write the example. I will take ethene here. This is ethene molecule. Undergoes polymerization. Undergoes polymerization. This is N-type. So it continuously bonded like CH2 single bond CH2, 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 CH2. Correct? So this is again with N time it will also continue. The repeating unit, which is CH2 single bond CH2 N times like this. Understand? I wrote this in a straight chain. So here there is no branching, students. All the CH2 groups are in a linear form. Understand? So this one is what? Polythene. Why it is polythene? Ethene is the monounit. Ethene. So many times it is repeated. So poly means many. Many ethene molecule is polythene. Understand? Ethene, so polythene. If styrene is polystyrene. Understand? Like that. Next. Second one, branching polymers. Okay? Here. If the polymers has long chain. Right, after polymerization, so alternate single bond and double bond will change. So listen, here single bond CH2, here single bond will form. Where the place of double bond? Single bond. In the place of single bond, double bond. Okay, the single bond CH2, this is CH3. So students, same unit repeats again from here. That is CH2, CH3, double bond, CH, CH2. Understand? Number of isoprene units connecting with each other that forming a polyisoprene unit called as natural rubber. Understand? This one is natural rubber. This is a monomer of the natural rubber. Understand? So if this is N times, this one is N times. Here students, this is a straight chain along with the branch. This is a straight chain along with branch. So this is called as what? Branched polymers. So linear means straight chain polymers. Branched means along in chain, branching is also there. Here there is no branching, only long chain is there. Understood? Linear and branching. That tells about what? The shape or structure of the polymer unit. If it is straight chain, that is linear. If it is a straight chain with branch, then it is a branch. Another one is a cross-linked. Cross-linked means the name itself tells about they are interconnected in a crossed manner. Cross-linked. And right? Okay. So what are cross-linked polymers? The polymers interlinked between two functional groups. Two functional groups. Understand? So in the same molecule, two functional groups are there, then they are interlinked with each other. Understand? So example for the cross-linked is, you may take which one? Okay, this is hexamethylene diamine. NH2 group is reacts with adipic acid. That's CH2 twice 4 times COOH COH. Okay, students. You know here COH is written as C double bond O OH. Here NH2 group is there. Understand? Here, either by losing a water molecule, they form a polymer unit. Or by either. Here, another CO group is there, functional group. There may be a possibility of linking a molecule of nitrogen with this molecule. Means, if two or more molecules is there, if NH2 group is there, COOH group is there, it may be like NHC double bond O. They may form this group or each other. Means here C double bond O is there, it may attach here. Interlink, just a force of attraction between. So listen, here hydrogen is there, correct? And write this hydrogen here. So there is a formation of a hydrogen bond here, correct? So here it will form a bond like this. This is what? Cross-linked. Understand? If in the same molecule, two or more functional groups are there. If in the monomer units, two or more functional groups are there, by the hydrogen bond or any other force of attraction, they form a cross-link. That is called as a cross-linked polymers. Here I have the polymers interlinked between two functional groups. Understand? So that is cross-linked polymers. But the important thing for you is linear branch. This is not in NCERT, but I explained you. This type of polymer is also there, cross-link. This is the example. Okay? So this is all about, students, about structure. So based on structures, they are classified as linear, branched and cross-linked. So the next one is intermolecular force. Next one is intermolecular forces. In that, the first one is elastomers. Okay, this intermolecular forces. First one is elastomers. So listen, the polymers having elastic property. Elastic property are called as elastomers. Understand? The polymers having elastic property are called as elastomers. Okay, so example for this is rubber. Natural rubber it may be or synthetic rubber. Okay, rubber is the best example for an elastomer. Next one. Okay. Fibrous polymers. So the polymers thread-like polymers. Thread-like polymers having high tensile strength. High tensile strength. Called as fibrous polymers. So thread-like polymers having a high tensile strength called as fibrous polymers. They are like a thread, you know. So example is nylon 66. You know, nylon cloths are there. Nylon cloths means the cloths are made up of threads. Correct? They are very highly tensile means they cannot break easily. They have very high strength. Understand? So nylon 66 is there, rayon is there, Teflon is there. So those are all examples for what? Rayon you may take. Rayon and nylon 6 is also there. Understand? So they are thread-like structure. Thread means they are like the fibers. You know, fibers also a thread-like structures, but they have very high strength. So here also, the thread-like structure are polymers having high tensile strength. They cannot be break easily. So those are called as fibrous polymers. Understand? So the third one is thermoplastic. Another one is thermosetting plastic. Okay. So I'll write the different students at the same time. The third one is thermoplastic. And the fourth one, thermosetting polymers. This is thermoplastic polymers. Okay. As we come to this, students, the first one is the structure. So these are the intermolecular forces. So these thermoplastic polymers are linear or branched, structures. Linear or branched structures. Understand? So I'll say first only this one. So these are addition polymers. These are addition polymers. I'll explain what is addition and what is condensation later. Okay. So first one, they have the structure linear or branched structure. Second one, they are addition polymers. So students, another one is where they become soft on heating. Soft on heating and hard on cooling. They become soft on heating and hard on cooling. At a time, they respond for a heat energy. Understand? Upon heating, they become soft. Upon cooling, they become hard. And these can be reused. These can be reused. So example for this is students, PVC, polyethylene, polystyrene, etc. Understand? So this is what thermoplastic polymers means. The thermoplastic polymers are the linear or the branched polymers. They are the addition polymers. Means these polymers are formed by the addition polymerization. Understand? So what is addition? What is condensation? Later I will explain. Another one is they become soft on heating and hard on cooling. Okay, and these can be reused. Means so many people used to collect the waste bottles and waste covers. Why they used to collect that means because they can be reused. They can be recycled. Understand? I think you may always used to see the people who is picking those polythene bags. Understand? Those bottles, water bottles, you know that. Okay. So because they can be recycled and they can be reused. The example for that is eel. Understand? Okay. So here students, opposite to this. These are linear or branched means, of course, these are cross-linked polymers. These are cross-linked polymers. Understand? So listen, if they are addition polymers and these are condensation polymers, only the difference. Condensation polymers. Remember, what is condensation means? Removal of water molecule. Next, they become soft on heating and hard on cooling. But they become hard on heating and become infusible. And become infusible means once we eat this type of polymers, they cannot be reused. Understand? So here cannot be reused. And the example for this is bakelite. Understand? So example for this is students, that is bakelite. Okay, so this bakelite is used in switches, wires, electrical appliances. Okay, that is bakelite. Once it is in the electrical appliances, if you use bakelite, once it burns means we cannot reuse that. It is waste. Understand? That is bakelite. This is thermosetting polymer. Okay, so this is the difference between thermoplastic and thermosetting polymers, which is important for quizzes. If you wrote this much, you get 2 points. So what is the difference, students? Here these are linear or branched straight. Sorry, thermoplastics are polymers are linear or branch-ended polymers are branched structures. So thermosetting polymers are cross-linked polymers. Okay. Next, these thermoplastics are obtained by addition polymerization. They are called as addition polymers. And these are obtained by the condensation polymerization, hence they are called as condensation polymers. Next, so these thermosetting plastics they become soft on heating and hard on cooling. Here, the thermosetting polymers become hard on heating and they become infusible. Okay, it cannot be, if they become infusible means upon cooling they cannot change their structure once they heat it. And the next, they can be reused and they cannot be reused. So here example is PVC polyethylene polystyrene. Here the example is right. Understand? Okay. So the next one is based on polymerization. So students, based on polymerization, they are classified as addition polymerization or addition polymers, let's say. Next, condensation polymers. 2 types. Condensation polymers. So I will write the example, then you will easily understand what is addition, what is condensation. So here I will take the example of ethene. So upon polymerization, okay, so this is N times means it will form CH2, 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 so on up to n times. Correct? Okay. So here, why it is called as addition polymer means here the single bond. So double bond changes to single bond. Double bond changes to single bond. And at the same time, students, you know, when this ethane will become ethane means when this double bond changes and the two extra atoms are added to this. When H2 is added to this, then only this becomes CH3 single bond CH3. Means addition have to take place. Here from the double bond it is changes to single bond means there is the addition of a molecule. Understand? So that is addition polymerization. Means the polymerization takes place by the addition of a monomer unit. Understand? Here I write polymerization takes place by the addition of monomer units called as addition polymerization, and such type of polymers are called as addition polymers. Understand? Okay. Polymerization takes place by the addition of monomer unit called as addition polymerization. Addition takes place means addition. So the such type of polymers are called as addition polymers. Example is this one is ethene, this one is polythene. Actually, this is written in this manner n times. This is the partial structure of a. This is structure of a monomer unit. This is partial structure of a polymer. Understand? What is that? I explain later. What is partial structure? What is monomer structure? What is polymer structure? Everything. Because the partial structure is also important for 1 or 2 marks. Next, what is condensation? And right here, I'll take hexamethylene diamine. CH2, 6 times NH2 with this. Understand, students? So here what happens? Polymerization takes place. Then what happens? So listen, here height NH and H. NH2 I wrote like this. Here also NH, H. Understand? Here I write this one as C double bond OH. Correct? And just writing the exact structure of those to show you what is condensation polymer. So students, here also you may write C double bond OH. That's the carboxylic acid group. Correct? So here condensation means removal of a water molecule. Okay. Next, here it becomes single bond. Because this H will also remove with another molecule of OH. So it will form a partial structure. We cannot consider this. NH, CH2, 6 times, NH, H2O remove means C double bond O here because NH after NH, C double bond O. Next, CH2, 4 times, only C double bond O because this OH is removed by another molecule of nitrogen, hydrogen of the amine. So this will continue. This is a partial structure of a polymer. This one is hexamethylene diamine, this one is adipic acid, this is nylon 6,6. Structure of nylon 6,6. Understand? So this is called condensation polymer. What is condensation polymers? The polymerization, and right here, polymerization takes place by the remove the water molecule. Remove the water molecule is called as condensation polymerization, and such type of polymers are called as condensation polymers. Okay, so students, example for addition polymers is PVC is there, natural rubber is there, isoprene synthetic rubber is also there. Okay, and also polythene is there, polystyrene is there, polyacrylonitrile is there. Those are all examples for addition polymers. For condensation, nylon 6, only two. And condensation polymers are only two, nylon 6 and nylon 6. Another one is there, dacron, but that is not that much important. Okay, this is all about the classification, students. In the next class, I'll explain you about how the polymerization takes place, what is the monomer units, their structure, polymers and their structure. Understand? Okay, thank you.